In this session, we will be taking a look at Unified Robot Description Format or URDF, which is used to visualize the structure of our robot. For that, we need to install one more package. Let's start. Sudo apt install. The package name is ROS Jazzy URDF tutorial. Enter the password. As we can see, there are some other packages which are also required. Let's go ahead. Okay, so to start, we'll be creating our file with the command touch robot.urdf. Let's start coding that file with VS Code. So URDF file are XML files containing the information about the structure and the dimensions of different parts of robot. Let's start with the XML tag. Version, call it a version 1. Put the tag. Okay, we need to make sure that it is recognized as XML file. So let's click here, auto detect. So URDF file start with the tag robot. Let's give a name to our robot, call it new. For the structure of robot, every part is considered as a link. So the next tag will be the link. Let's call this link as link. Now we need to provide the details about the visuals. So the next tag will be visual. Inside the geometry dimensions, and the shape, which in this case will be the box. The size inputs will be, let's say, 0.6 in length, 0.4 in width, and 0.2 in height. As we are not going to add anything new in the box tag, so let's close it here only. After geometry tag, one more information that we need to provide is the origin, and let's keep it by default in X, Y, Z 0, 0, 0, and the role pitch yaw is also 0. Close the tag. Okay, this is our first link. Let's try and see it. First, source the environment. Let's run the package. Display.launch.py. The argument will be our newly created file, which is in the home new one robot.rd. Okay, so this is the first link that we have created. As we can see, the half of its height is just below the plane. So let's fix that part first. For that we need to change the origin along the z-axis. So it needs to move up by half of its height. So let's take it 0.1. To have a better visualization for our different links, let's create few material colors using the tag material name, call it red, color RGBA. R is red, green, blue, and A is alpha, which defines the transparency. So red is 1, green 0, blue 0, and alpha is 1. We don't want it to be transparent. Let's close this tag over here only. This is our first color and two more here. Let's get green. R will be 0, green will be 1, blue 0, and again 1. Then one more color, call it blue. So red 0, green 0, blue 1, alpha is also 1. So these are the color tags that we can use here inside the visual tag. It would be below the origin tag. So material, use the red color. So this tag here only. We can change it blue. Let's try to run it again. ROS2 URDF tutorial play.py. The model argument is going to be home one, which is a part of our URDF file. As we can see, the two changes that we did. First, the location is above the plane now. And as we can see, the default color has changed to the blue. So this is the first part, which is a cuboidal base. So let's add few movable arms over this. For that we need to create one more link. As we said earlier, link is just a part of the robot. So name, let's call it arm1 link. Well, inside the visual going to be geometry tag. Inside the geometry tag we are going to add the shape. As we want arm, so we will be calling it cylinder shape. In case of cylinder, we need to pass on two arguments. One is the length, so let's keep the length at 0.3 meters, and the radius will be 0.05. Let's close this tag over here only. After geometry tag, let's add origin. By default, 0 in x, 0 in y, 0 in z. then roll pitch yaw, 0 roll, 0 pitch, 0 yaw. Material, and let's keep it red. So the material tag, and now we have two parts or two links. Now once we have these two links, we need to join them by giving the description of that particular join. Let's create join. Name is going to be, as this is the joint which is connecting the base with the arm, so let's name it base arm 1 joint, and the type of this joint is going to be resolute. Okay, inside this joint we need to provide the parent link. So parent is going to be base link, close the tag. Child link is going to be arm 1 link, close the tag. And the origin of this joint, let's again by default keep it 0 0. First we will visualize this joint and then we will change these values as per our requirement. Then roll pitch yaw, close the origin tag. After origin, as we have provided, this is a revolute joint, means it's going to revolve. So we need to provide the axis about which it can revolve. So the axis YZ, and we want it to revolve along the Y. So X is 0, Y is 1, and Z is also 0. Close this tag. For revolute joint, one more data that we need to feed is limit, means how much it can revolve clockwise and anti-clockwise. So the lower limit, put it in radians. We want it to revolve by 90 degrees, so in radian it will be minus 1.57 radians. On clockwise direction, positive 1.57. Few more information, effort we will discuss later. As of now we can put it like 500. Then velocity, keep it at 500 only. These values don't matter as of now. This is the joint which is defining the connection between the base link and the arm link. Let's visualize it. First save the file, need to exit the process in the same command. While passing on the model argument, just pay attention to that colon over there. Path to our file is same, home admin1 robot URDF. We have the joint. Let's take a look at this. So as we can see, our newly created link, to which we have given red color, as per its origin. It's at the center of the plane, and if we want we can try to revolve it like this. So we want it to be on the top of this box so that it can act as an arm. So first thing that we are going to do, let's disable the robot model. Look at the links. So this is the position of link which we want on the top of the box. So as we can see, the height of the box that we had provided is 0.2. So our link over here, the origin of that joint has to be moved by 0.2. Let's run it again. Yes. So as we can see, now the second thing that we need to change is the visuals of this particular link. So as we can see, it is half inside the box, so it has to be moved by half of its actual length in the upward direction of Z. So this change has to be done in the origin of the visual of that particular link. So the length is 0.3. The origin shall be moved by 0.15. Give it a try. As we can see, the link is exactly at the surface of the box and the visual is above the surface. Let's try the rotation, 90° clockwise and 90° clockwise. Okay, let's add one more arm above this, which will be our link T. Name arm to link. The visuals in geometry tag, again it's going to be cylinder. This time let's change its length a little bit. So let's keep it 0.5. Radius let's keep it same, that is 0.05. Close the tag. After geometry tag, the origin tag, again by default let's keep it 0, and after visualizing we will change those values. So 0 in X, Y and Z. Roll pitch off, again 0. Close the tag. In the material, so we had used red blue, we are left with the T. Close the tag. So this is the third link or third part, and just we will connect it or join it with the arm 1. So the second joint is named, in this case the arm 1 is going to be parent, arm 2 is going to be child, type is again going to be same, evolute, parent link, is link. Child link arm2 link origin of the joint, keep it to the default values, x, y, z. Roll pitch yaw, then limit. Again we want it to revolve by 90 degree, so minus 1.57 per is going to be, these values has to be entered in radians, so 90 degree in radians is 1.57. Effort, keep it to 500. Velocity, keep it to 100 as well. Use the tag, and our arm 1 and arm 2 are connected by this joint. Okay, one thing is remaining, that is axis of rotation. So x, y, z, we want this one to be rotating from the y only, so 0 in x, 1 in y, and 0 in z. So we have 3 links and 2 joints. Run them again. Okay. So as we have two joints, so these are the two sliders. As we can notice, the problem is that third link, which is in the green, should be on the top of this red link. We need to move its origin by the length of this red part. Let's take a look, and as we can see, the length of arm 1 is 0.3, so the joint should be moved by 0.3 in the Z direction. Let's give it a try. Okay, so the first problem is solved. Now the visual has to be moved by half of its length in the positive Z direction, which has to be done in the link, the visual part of the link. So as we can see, length is 0.5, so origin in the Z direction will be shifted by 0.25. Run it again. Right, so both of our links are perfectly placed. Let's disable the robot model. Take a look at the 3 links that we have created. These are the sliders which can be used to move those joints. Let's start with the second joint. So as you can see, we have a very good visualizing model base over which we have 2 arms which can be rotated using these sliders. and this is the 90 degree turn.